So, hey guys, in this lecture, we'll be talking about availability. That is our next. That is our next application characteristics. We all have already talked about latency and throughput. So let's talk about what availability actually means and what are its implementation and applications. Cool. So, for example, when we book a ticket, for example, we book a bus ticket from different apps like Redbus or whatever. Cool. So, sometimes the server is not responding. Server is not responding. Sometimes the server is not responding. So, what happens is it is unavailable, or and if it is unavailable at the time user needs it, it gives user a very bad experience. And all the companies, as we discussed, are customer centric. So the time they want the service to happen, at that time is if our server is not responding and also it's unavailable, then the bad user experience kind of thing takes place, and it makes the app annoying, or it's likely to happen that a user cannot will not use the app in future or will not recommend it to anyone else. So automatically the market of that app will go down. So basically, availability we can define as the probability of whether a system will work as needed when we make a request. So this is the definition of availability. It is very important, guys. One of the most important application characteristics and one of the most important thing that any product builder take account of is availability. Cool. So it's basically the performance measure. How good our performance of the system is. It's the performance measure of the system. So why these big tech firms like Google or Facebook are so successful? Because they have very supported system. The performance of their systems are very great levels. Cool. Now let us look at the different impacts, what impact they have on the architecture part. Cool. So for the monoliths, if I say that monoliths have a single point of failure, single point of failure. So for example, if I have written these lines of a 1 2 3 4 5 6, if some occurs at 3, then the whole system will be unavailable. So the monoliths have low availability because of this reason. And contrary to this, for the distributed part, they are highly available. For example, if some of the features are not available, yet it could serve certain customers that are looking for some another feature. So they have multiple features in different machines. Cool. So if one of the machine is not available, yet the app or the web app can deliver at least few things to the customer. So that's why the availability in case of distributed is higher. Cool. Cool, guys. Now we'll talk about another important aspect, that is an important term widely asked, is fault tolerance. fault tolerance. So in distributed system, if we have certain fault or we have certain problem, so it is handled by fault tolerance, and fault tolerance is redundancy and replication. If we make our system fault tolerance, then availability will automatically go higher in the distributed systems. Distributed systems. Cool, guys. So this is one of the important thing that we need to know, how we can increase the availability. Also, there are certain more factors, like first is we need to eliminate the single point of failures. I hope you already have understood this point. Second, we should keep updating things, softwares, hardware, or whatever, as we discussed earlier. Third is we should have an excellent support system. Google is so successful because it has such excellent support system. Cool. And we should ensure automatic failover. If, for example, if some of the feature is not available, we need to redirect to a copy of that same service. So the process should happen likewise. So if we keep these things in account, so the availability will increase highly, and at the same time our system will be available to a lot of user, and we will have a great market and a great ecosystem. So thank you guys, we'll meet you all in the next lecture.